Okay, hi, hello, good morning, good evening, good day, everyone, and welcome to our today's webinar. So, still, I think we are waiting for someone to join us. First of all, I would like to introduce myself. My name is Lidiia, and I'm excited to have you with us today. So, before we start, let's make a quick sound check. Please write down plus if you can hear me. It's important for me to understand that systems are working properly and you can hear me and Semyon today. Please write down plus in the chat.
Hello, Lidiia, I hear you.
Okay, great. You can hear me. I see also pluses in our chat that in another person's also can hear me. Yeah, great, great. More pluses. That's good. Okay, that's great. So before we start, I just make a quick introduction. So we are going to explore today the SELinux, so basic and practical sandboxing with type enforcement. So we also will be joined with Semyon a little bit later as our experienced expert in system security who will lead us through the technical details and practical demonstration. So first of all, in order to understand our auditorium better, I have some questions for you. Please, how familiar you are with SELinux? Just you have to drop one in the chat if you're just a beginner, if two, if you something in the middle, or three, if you are as a Linux Pro expert. You can also write 1.5 or 2.5 if you're something in the middle of these. Yeah, please type your question, just a simple number. So I will take a look at your responses to get a feel for where we are staying today. That will help for me and Semyon to understand our auditorium better. So yeah, while waiting for your answers, I would like to give you some interesting piece of history in order to kick this off. So do you know that SELinux was originally developed by the National Security Agency? It began as a research project to address gaps in traditional Linux security models, and today it's a critical security layer for industries like banking, healthcare, automotive, and environment and government system. Simon will provide you for later bit with more facts today, and I just give you a key insight. Okay, wonderful. So, Simone, in most cases, some of our users already know what is SELinux, and they would like to hear, like maybe some more proficient, but some of them are also the beginners, so just take account on this too. So whether you are an IT administrator or a system developer or just someone looking to strengthen your cybersecurity toolkit, today's session is designed to provide you with actionable insights. So just just think about how secure are the system you are managing right now? Could they withstand a target attack? So by the end of the webinar, you'll have a practical strategies to enhance your system dependencies using SELinux. So why this topic is so important today and why we choose it? Because in the modern cybersecurity landscape, reactive security is no longer enough. Proactive measures like SELinux Type Enforcement module are critical to staying ahead of threats. SELinux ability to enforce mandatory access control means that even if someone gains unauthorized access, their movements will be tightly restricted. So that's why another quick pull for you. Just please think and write down how many of you have dealt with situation where a misconfigured permissions led to a security vulnerabilities. So feel free to share your experience in our chat and some interesting stories we will be glad to discuss during our Q&A session. Just I would like to ask to repeat my question. So how many of you have dealt with the situation whether misconfigured permissions lead to security vulnerabilities in your real experience? And now to get us started, I give a word to conduct the webinar further for our Linux expert Semyon, who is ready to guide us through the fascinating world of SELinux. Semyon, take it away.
Hello. So thank you, Lidiia, for introduction. My name is Semyon Boyko, and thank you for joining this webinar. So, a little bit agenda. I will start with a brief history of SELinux to give a context on where it came from and why it was developed. We will also discuss discretionary access control, which is DAC, with mandatory access control, which is MAC, highlighting why SELinux uses mandatory access control as a key part of its security model. Also, in the next section, how does SELinux work? I will explain how SELinux enforces the security through labeling and type enforcement. This section will clarify the basics of the SELinux and how labels are applied to the files, processes, ports, and other resources, and how type enforcement restricts interactions based on these labels. At the end, the sandboxing processes using SELinux Type Enforcement. Finally, I will dive into how SELinux Type Enforcement model can be used to sandbox processes, providing some kind of additional layer of security in multi-user, multi-service environments. Through the entire webinar, feel free to ask any questions or save them for the QA session. I also have a couple of quiz questions during this webinar, so you should be ready for them. So what is SELinux? The SELinux stands for Security Enhanced Linux. It is not some kind of another operating system or whatever. It is a security architecture integrated into the Linux kernel. It provides a mechanism for supporting access control security policies. It's developed by National Security Agency, and this National Security Agency in 2000 released the SELinux to the open source community, allowing everybody to use this in their distributions. It was later integrated into the Linux kernel and various distributions such as Enterprise Linux, Fedora, Debian, Ubuntu, making it standard security feature in many Linux environments. So It consists of Linux security modules, which is the kernel part and which was developed by NSA initially and modified and improved by the years. And from the other hand, different distributions provide their own user space packages and user space utilities. Like for Red Hat, it's called SELinux, and Ubuntu provides its own Apriorit, which also uses the same Linux security models in the kernel. So before discussing the SELinux and how we can use it and its basics, we need to understand what means DAC and what means MAC. So DAC stands for discretionary access control, and it is the default access control model used in Linux and used in Unix systems. Under the DAC, the owner of the file or resource has a full authority to set up permissions and determine who can access it. The permissions and the ownership in the DAC represented by user group and others plus permissions. So users have an ability to change the permissions on their files. Actually, the user can make the chmod 777 on his home folder. Don't do this, and nothing may stop him. So in DAC, root has ultimate control and can override all permissions, making it the most powerful user in the system. So the root is considered like omnipotent on the system. On the Mac system, which is represented in the SELinux, is an example of a mandatory access control. On the Mac, there is a policy which is administratively set and fixed. Even if you change the DAC settings on your home directory, if there is a policy that prevents another user or process from accessing it, you are generally safe. This ensures greater system-wide control and security, preventing unauthorized access even if root privileges are compromised. So this difference is a key reason why SELinux is used in environments where security is critical. So the mandatory means mandatory, so you can't change the policy, you can't load different policy, and you can disable the policy. These policies are administratively set. Now, in modern systems, DAC and MAC works together. Like, for example, Android started using SELinux, which implements mandatory access control, starting from version 4.4 KitKat. This added an additional layer of security to Android devices, ensuring that even if DAC permissions were bypassed, MAC policies would still enforce strict access control. Now, let me ask you a question. This is the first question in this webinar. What do you think happens when you root your Android device, and does it break both DAC and MAC?
Yeah.
Yeah.
Feel free to write down your questions. It would be interesting to know your opinion. So, Semyon, could you please repeat the question one more time? Maybe for those who missed.
Take a moment to think about it. And does the routing gives a user complete control over the system? Does it break the DAC and MAC?
Yes, the answer should be simply yes or no. Just truly saying I was already know the answer, but I was asked this question by the Semyon when we were preparing this webinar. And just if you would like to know my answer was no, but I will not tell you if it's right or wrong. Just would like to hear your answers. Just simply, we are waiting for your answers. Just, we would like to know, like, yes or no, what do you think? And based on these examples and based on the information that Semyon provided to us. Okay, good. I already see some answers. So, Semyon, I think it's enough time that we give, yes, to our auditorium to think about it. So, please tell us the right
So
answer.
the answer is the routing of the Android device will break only the DAC. So if you even rooted the Android device, you still have to complete the mandatory access control system and still need to follow the mandatory access control system, which sets the policies administratively from above, even for the root.
Yes, actually, this reminds me one of our current project, and I would like to share it with you. So we have a system application with root privileges on the Android device, and essentially, it also serves as a marketplace for the third-party applications. So, in order to protect ourselves from potential malicious third-party applications, SELinux comes here to rescue us because, as already Semyon mentioned, the Linux are in Android devices in the KitKat versions. Yes, where are all those versions? So in modern Android devices, it as Linux helps us to protect a device from the unauthorized access with third-party applications. Yeah, please, Simon, go ahead.
Thank you, Lidiia. So SELinux policies at the core of SELinux. They enforce the security, so these policies define what can and cannot be done on the system. They control the access between users, files, directories, memories, sockets, and ports, and every resource that actually exists on the system. So these policies can be very fine-grained, making it powerful tool for enforcing mandatory access control system. So policies. The SELinux operates with two main type of policies. Targeted, which is default policy in most SELinux enabled systems. It focuses on confining specific processes that are more likely to be exploited, such as web servers or database servers. All other processes run in unconfined T domain, which is not confined. And MLC policy stands for multi-level security or multi-category security. It is used in environments where highly sensitive data needs to be managed with strict classification levels, and in such structures like government or military systems. This is very complex and it is out of scope for today's discussion. So, how does it work? SELinux operates in three modes, which define how it behaves on the system. The none, in which the SELinux is completely disabled. No SELinux security policies are enforced and nothing actually happens. Permissive, in this mode, SELinux policies are not actually actively enforced by violations of the policy known as access vector control denials. It's often just used for debugging and testing, so you just see the logs about some kind of errors that would be happen, but they actually are not enforced. And finally, enforcing. This is the active mode where SELinux enforces its policies and denies any actions that are not explicitly allowed. This is actually the recommended mode for production environments to provide strong security on the system. Also, SELinux has key configuration files and tools that allow you to check and manage its state. So etc SELinux config, this file determines the SELinux mode on the system boot. You can edit this file to change the SELinux behavior permanently. The se status command gives you overview of the SELinux status, including more it is running and its loaded policies. And get enforce, set enforce, actually these tools allows you to check the current SELinux mods they are running at, and you actually can change this mode on the runtime. So two of the important concepts to understand with SELinux are labeling and type enforcement. So every file, process, and resource in this system has SELinux label, also called a security context. These labels define the type of the object, the file type, the process type, and they are critical to determine what access is allowed. Labeling ensures that SELinux policies have necessary information to make access control decisions. And from the other side, the type enforcement, this is the primary mechanism for SELinux that uses to enforce the security. Type enforcement uses these labels that I mentioned just that assign it to files, processes, ports, or whatever on the system to control the access. So these policies define which type of process can access which types of resources and how they may use them. For example, a web server process may only access the web content file, not the system configuration files, or etc. Sorry. Labels are present in such format like user, role, type, and level. For the purpose of this presentation, we will not deal with the SELinux user, role, or level. These are used in more advanced configurations of SELinux. But what we really care about for today is the type T, which actually defines the label for the specified file or process or whatever. Now, how do I deal with those labels? When working with SELinux, understanding and managing labels is essential. Many Linux commands support the capital Z command, capital Z param, to show the SELinux context of the files, processes, networks, ports, and other resources. So these commands actually support this param, and you may see you may see the for the ls capital Z, you may see the context for the files in the home directory, and for example, this one has user home T. The ID -Z shows the SELinux context of the current user, which is unconfined on this example. The PS -Z should display me the context of the running process, and netstat -Z shows the SELinux context of network connections. By using capital Z flag with these commands, you can quickly identify and verify SELinux context, ensuring your system policies are being applied as expected. So that's how we deal with those labels, and we can see them. Now, on the other hand, we have the rules. SELinux operates on the strict rule-based system, and the fundamental principle is everything is forbidden unless it is explicitly allowed. So access vector rules determine what interactions are permitted between processes and objects. These are four types of access vector rules: allow, don't audit, audit allow, and never allow. So, for example, here is the format of these rules. You have the rule name, the source type, the target type, the class, and the type of permission that is allowed. For example, allowed. Like in the allow rule that checks whether the operation between the source type and target type are allowed for the class and permissions defined. So here you can see, like in this sample, This means that init rc type process can interact with the acct exec t file type, allowing such permissions like get, utter, read, and execute. So next one is don't audit, and this is useful when you know an event that will occur, but you want to suppress audit messages about it. It's just to avoid noise in your logs for events that you don't care and you don't need to make any attention on them. This in this particular sample, the stop audit messages for the trace role T process attempting to bind to the TCP socket port. Now then we have a audit allow rule that actually audits an event as a record. It actually what it's doing, it specifically records an event for auditing purposes, even if the action is already allowed. So in this sample, like here, your process of type ada.t has execute stack memory, and when it does it, you will still see the record in the logs about this allow rule. But this rule actually doesn't allow anything. It just makes audit of any allows. You still need to explicitly use allow rule to allow this action. And finally, the never allow, which ensures that certain permissions are never granted to anything. Like in this sample, this explicitly prevents processes with HTTPD T type, like web server, from reading files labeled with shadow T type, like etc shadow file. So this what important in this example is that never allow is enforced at a compile time. If you try to write an allow rule that conflicts with the never allow, SELinux will catch it during policy compilation, so you won't even get the binary form of the policy, and you won't even have an ability to try to install it because you will face with this rule. Now, this one is preconditions for the second quiz question to you guys. For example, assuming we have the web server, which is called HTTPD, which has a policy that's called HTTPD. The web server configuration directory is labeled with HTTPD config T. The web server log file directory is labeled with HTTPD log file T. The web server content is syscontent. The web server startup script is unit file T. And finally, the web server runs with the label HTTPD T. So these labels are fundamentals in SELinux and ensure that the web server only interacts with the specific resources it's allowed to interact. Now, on the other side, let's switch to a security critical file that's called etc shadow, and the type of this file is shadow T. This file stores sensitive data like password hashes for all users on the system. Now, how do you think it makes sense for a process running with the HTTPD T context label to be able to interact with the file that has the shadow T label? Do you think it makes sense for a process to define those rules at all?
Yeah, so please type yes or no. Just we need to understand your opinion. And by this question, we somehow check how carefully you listen to Semyon, because in his previous slide there is an answer, right, Semyon?
Yes. Yeah.
It's to please think a little bit and answer the question just yes or no. Do we need to set up our explicit between? Okay. The direction, no or yes? Okay.
No.
No. Yeah.
No. Yeah, I think it's no, but yeah, it's totally right because yeah, because everything is denied unless it is explicitly allowed. So you don't have uh, to deny everything because everything is already denied. You just need to type the allow rules in the SELinux policies just to manage the HTTPD, which is actually, I think it is policy for Apache web server.
Yeah, that's correct. So because during our work, yes, we often maintain web servers like hosting servers and hosting systems that many manage the web services. As we can also apply the principle of least privilege to these services. So this approach involves specifying exactly where the HTTP service is allowed to access and what it can execute, nothing more. Like Semyon told that everything that is not allowed, that is,
Everything is denied.
yes, that everything is denied. Yeah, please continue. Thank you for your answers.
So this is a sample. Sample. It's not the entire policy, just a sample that fits the slide. And this is a sample of the policy that displays the allow rule for the HTTPD. It explicitly states that the HTTPD can perform actions like read, get utter, and open on the object that called HTTPD config.t class file. Now, what? Yeah, what does it mean if I get SELinux errors? When SELinux throws an error, it could be due to a few reasons. Could be incorrect labeling. It could be the bug in the policy itself, and it finally may be the policy restriction that policy might intentionally deny access to the resource based on the security rules in place. So if you see such errors, check labeling first. Use tools like ls minus capital Z param to inspect labels. Review the SELinux policy if you wrote it, and confirm that if this is behavior is intended, and if needed, adjust the policy to allow the action or fix the incorrect labels. Yeah, and this goes to the last section of this webinar. It's called Sandboxing Processes using type enforcement. Before writing our own policy model, I want to show you that actually a lot of tools, right, like on Red Hat Enterprise, they provide their own utility that's called Sandbox. And what it's doing, it sandboxes the entire process in some kind their own policy that is defined and called like sandbox T. Like in this sample, I'm running the bin bash process with the home folder sandbox test. And here you can see the process is isolated from the rest of the system. It applies the sandbox T type for the bash process. And what it's doing, it sends the sandbox file T type for entire list of the files in its home folder. Also, I don't know, I just viewed the source code of this Python utility, and what it's doing, it's actually randomly calls random function, and it just generates the categories like C212 in this case and C710, and what they are doing, it just applies to all files and the process itself. So the bin bash will be limited with the sandbox T policy, and it still will have access only to the files with this category. So this is actually a great utility that you may use to sandbox, but it just limits you to the single file or single directory with the home folder. Yeah, now I want to show an example how we may write our own SELinux policy model And for this, we may use the SE policy generate utility, like in this sample. The first step will be to generate the policy itself. We will use the generate command to generate SELinux policy files. These files will be the definition of how SELinux applies its rules to the process. And also this command actually will generate me some kind of script that will just compile, build, and install this policy into the system. Oh yeah, next one is the second step would be to enable the domain transition between this my custom policy that called my bash t, and we need to explicitly enable a domain transition. This allows SELinux to move a process from the default unconfined T domain, which will be my my run user, to our new restricted my bash T domain. To do this, we will include this macros that call it unconfined run2 to the my bash type enforcement file. This macro allows processes in unconfined domain. This is actually the default domain for the most user processes to transition into a custom domain my bash t when executing them my bash exec t labeled file. And yeah, so that's how it will look like from initial. And yeah, to install it, I will use the generated script my bash sash under the sudo, and to run it, I will use the run command. Now, I would like to share the screen in this interface. Screen. Touch screen. Share. Whoa. Lidiia, do you see my screen?
Yes, I can see a screen.
Okay, cool. Right. So this is my regular Red Hat release. It's Red Hat Enterprise Linux 9.2. And here I already used my generate utility for my policy. I generated these files. This one is for the man, but we don't care about them. This one is most interesting. It is my policy type enforcement file, which actually defines the policies itself. And this is just a bin bash process that I copied to this folder to play with it and change its labels. So to install it, I can just use my bash, my policy sash, sorry. Oh, it's already up to date. So yeah, I will just install my policy, and on the second terminal, I have the tail command that audits the audit.log events. So this is actually the installation. We don't care about this error because it is just a generation of the RPM package, and I don't need it, so I did not install even the utilities to make them work. So the policy is installed, and now I can run it like, with the type my policy t and my bash. So here I just run it, the bin bash process, which has a permission denied for even to this file, and as you can see, I'm not able to access any folder, but I actually able to execute ls id or whatever command I want. That's because I think I forget to remove some kind of macros that allows me something. Let me check. Yeah, so that's how the policy file looks like. It defines the attributes. It defines the roles, and it actually has this macro that allows me to run from the unconfined domain to my policy domain. And here I have this macro that I just forget to comment out. Now I won't be able even to, I shouldn't be able even to execute the bin utilities in the system. Waiting for installation. So now let's run it. Now you see, I even cannot access this bin ls file and cannot go and execute something. But everything of that is happens for my regular user, which is with just as boy name. But what will happen if I got the root access? It's the same. As you can see, this is a root invite, and I still cannot access anything from this perspective, and I cannot execute any utilities from the bin process, which actually means I limited even the bash that runs under the root. So this is how we can just create some kind of sandboxed policy and go with it. And on the other side, we can monitor the ODD logs to see the all denials that I just got here as a. And from these denials, I can, take this message and create additional allow rule or deny rule that makes me possible to generate a strict requirements and strict policy for my, for example, bash process to execute or use something on the system. So that actually how we can start to create the sandboxing for the process. And let's get back to the presentation. Stop sharing. So why do we need at least at all, why do you need to sandbox something? This example with bash shows just how powerful SELinux can be for limiting what applications can do on the system. Using SELinux Type Enforcement model, we controlled what bash could access, keeping it from running commands like ls or whatever. This level of control is required for high security environments where strict access control is needed, such as hosting environments, to isolate web hosts and cloud providers. Use these SELinux policies to isolate user applications, preventing one user application from accessing another data. On embedded systems, in devices with sensitive data, making it hard for attackers to access critical resources. On enterprise servers, servers that often run a mix of third-party applications, some of which may have security vulnerabilities or zero vulnerabilities. SELinux can help contain these applications within some kind of sandboxed policies, limiting potential damage that they can do to your entire system when someone just broke them. In general, SELinux sandboxing is useful whenever you need to enforce strict boundaries around the applications. This approach reduces the risk of unauthorized access or privilege escalation by tightly defining the permissions associated with each process. So all of that is actually defines the least privilege principle that allows you strictly define how the process may interact with another process and how the process may interact with the system at all. So the example we used just is a simple demonstration, but with SELinux you can build policies that are as complex as needed. Lidiia?
So yes, thank you, Semyon. So I think this is the end of our presentation. And thank you very much for such great and insightful topic. So we have some questions already. So please help to reply on it. So the first question, how does it relevant for today architecture of using Kubernetes?
Well, since the Kubernetes is already Dockered under the container, you already limited it with the list of capabilities, but it is a container. It's not just a single process. You already limited it with the containerization in the Kuber. So it is another type of sandboxing.
Thank you, Simon. I hope we answered your question. So still we are waiting for more questions. So Simon, I would like to ask you a question. Because a couple of days ago, yeah, it was on Wednesday morning, in Canada, it happened the outage, like power outage, yes. And after this, when the servers were down, there some authorized access got the root privileges to the servers and caused some damages. Yes, to healthcare system, people can't get their electronic prescriptions. To the financial system, people can't get their money from ITM because it was stuck. People can't, even some in government sector, the transportation system also had some damages and losses. So what I see, it was the servers there on the Ubuntu, and they don't, as I understand, don't use SELinux. So please help me in terms of the SELinux. If it was the SELinux, somehow can it be stopped from this unauthorized access or not?
Well, yes, but look, they definitely would help you if you run the specific third-party applications or whatever on your server, and when it has a vulnerability or you breached something or get the escalation on the entire server, you can limit the access of the specific process to the resources on this server. And like this guy asked me is about the Dockers or Kubernetes. If the process will be breached and escalated, he will still be able to access the entire list of the resources in the Docker, not the entire system. So yeah, this would help, but it still depends on the infrastructure of those servers.
Yeah. Thank you, Semyon. We have another question. So first of all, thank you so much. Very interesting. So you applied policies in the real time during the presentation. Is there a way to hard code them so they would be applied to the whole system during the boot?
Well, when you install in the SELinux package, there is a default policy that is defined by the package distributor, like the Oracle for Red Hat, they write their own policy, which goes default. It defines the unconfined domain and other list of domains. And when you install some packages with RPM package, it also adds those policies to the global SELinux DB. So in my case, I just used the script, so it would be applied to the system during the boot. I don't get what means applied to the whole system, because I just managed the bin bash. But if you want to limit the bin bash during the boot with such small policy, yes, we can do this, but I don't think that the system will boot at all. So yeah, actually, if you use such things, you may break the entire system. So when you just developing something or doing with SELinux, please make the snapshot before you will try to enable it and enforce it. It's it's the beginning of our work with SELinux. We very often we got just broken system and had to revert to the snapshot because we just missed some policies or broke something.
Thank you. Another question we have. So thank you very much. What best practices do you recommend for writing and maintaining custom SELinux policies?
As I said you before, you just first of all you need to remember about the permissive mode. The permissive mode is a great stuff that actually logs everything and every denials and access events for your process or your domains that you're trying to confine. So start from the permissive, check everything that it writes to you, and only then go to the enforcing mode. And of course, again, still use the snapshot and develop this on the virtual machine.
Okay, thank you. Thank you, Simon. Maybe still some while our auditorium is thinking about another question. So I would like ask you also some questions that just came to my mind. At the beginning, I mentioned that Linux can help in many sectors. Yes, like healthcare sector, financial sector, automotive, banking sector. Just do you during your practical experience, have you ever faced with practice of the Linux in automotive sector? If yes,
Yeah,
then
yeah,
can you
yeah,
please describe?
yeah. For automotive, we had a single case for automotive science. The car provider, I don't know, they just developed. The modern cars they have the entire operating systems. It was I think it was an Android based or whatever, and the request was to write some kind of tool that allows you to debug all of these tools when you just get to the car and connect it to it and debug all of the systems on this car in the this ECU model. So when we developed such tool, we also it was like similar to the ADB command on the Android, if you're familiar with it. And what we have done, we also limited the access of this tool with the SELinux policies that just defined what kind of log files it is able to access and what kind of resources it is able to gather, and nothing more. So even if this tool would be uh, vulnerable to some attack or got some kind of escalation to the root, it still will be limited with the SELinux policy that was defined in the system and it was installed during the boot.
Thank you, Simon. Yes, it's really nice practical experience. So I think that we are done for now. No more questions. Thank you so much. Thank you for a great presentation. I think it's very useful for all of us, and some of you can find something interesting and you can apply it in real life. Oh, we have another question. Okay. It's not the end. Okay. The question is, what are the key differences between SE Linux and other access control systems like AppArmor?
Well, AppArmor is actually, the Ubuntu just goes with its own way how they define the mandatory access control, and AppArmor daemon it uses the same Linux security models from the kernel, and you may use and define these policies, but just in different way. Actually, the Ubuntu in its own repositories, it has the SELinux package, but from my experience, it was for Ubuntu 22 or 4, I think. When you install it, you actually lose your desktop session. So it has the, their own policies in the SELinux package has the bug inside these policies that actually did not allow to run the UI desktop on the server systems. So um, so the answer is, for the Ubuntu you have the SELinux package, but I wouldn't recommend to use it. Just use the Apriorit, which is very similar to the SELinux. It just has a different syntax of the policies and commands that you define in the etc. But you still can install the SELinux package and try to write the same SELinux policy as I just write here with with this sample for the bin dash.
Thank you, Semyon. I hope we answered your questions. So I think no more questions. Let's maybe wait one more minute. Thank you again to the Semyon. Thank you so much. And so if you have more questions, you can address it to ours. Yes, there is information about our website, and you can go to the LinkedIn, find me or Semyon, and address the questions directly there. We'll be glad to answer those questions. So thank you, everyone. Thank you, Semyon, and bye.